Okay, today we're going to extend our number systems. We looked at binary, we looked at octal, and now we're going to look at hexadecimal. What is hexadecimal? Well, the hexa means 6, or I don't know if the hexa means, I think the hex means 6 now that I think about it. The hex itself means 6, decimal means 10, and I think the means on. So it's like 6 on 10. I might be wrong, but 6 on 10, it's a 16. Now that part I'm right about. This is a base 16. When we say hexadecimal, we're talking base 16 counting. Okay, so remember we had some fun facts about place value system. And one of the fun facts will be, well, if it's base 16, there must be 16 faces on each dial on our odometer. On each dial. And a 16 must look like this. That will be a 16. Remember, that was a 2 in base 2. That was an 8 in base 8. It's obviously a 10 in base 10. It's a 16 in base 16. So here's our thing. Somehow we want to count from 0 to 16. And we'll start with a 0, of course. And we're going to end with a 16. And the 16 has to look like this, because we want this to be a 16's place. We want a 1's place and a 16's place. So how do you get from 0 to a 1, 0? Well, you go 0, you go 1, you go 2, you go 3, you go 4, you go 5, you go 6, you go 7, you go 8, you go 9. And then you got a bit of a problem here, right? Because we need another symbol. I don't want to write this. That's not a 10, that's a 16. Remember? In this system, that's a 16. I don't want to do that. I've seen people do this before. Don't let this be you, but I've seen people go like this before. They go, well, this is the 1s and this is the 16s, and I got 10 1s, and so they put a 10 there. No. You're only going to put one symbol on each place value system here, right? So how do we get around this? We make up new symbols. We could make up our own new symbols, like that stands for 10. That stands for 11. But what we do instead is we make it a little bit easier on ourselves. We go, that's, hey, what'd you do? We go, that stands for 10. That stands for 11. That's a 12. That's a 13. That's a 14. That's a 15. And then a 1, 0 is a 16, okay? So this is the part people kind of got to get a little bit used to here. A means 10. B means 11. C means 12. D means 13. E means 14. F means 15. We need to use letters with our numbers because, again, pardon me, we have to have 16 faces on each dial. What are you going to label them? You got to label them with, just symbols, just little symbols. You don't want to. So we use the A, B, C, D, E, F. Okay, and that's the big thing. That's the big surprise. We got letters now. The good news is, from here, it's all the same as what we've been doing. What we need to do, of course, is be able to convert back and forth, hexadecimal to decimal, decimal to hexadecimal. And I've got 4 examples here that'll do the trick for us here. Like example 1a. Okay, here's a number that, just in case you didn't know it, it's written as a base 16. It's written as a hexadecimal. Usually the A and the E are the dead giveaways. You see letters, you go, oh, must be base 16. But just to make it extra clear, somebody put the 16 on there, which is a good idea, because what if I had like this number and I meant that to be not a 55, but a 55 base 16? Well, then the base 16 really is important to put there, right? So anyway, we got this hexadecimal number, 1AE, and we want to make it a decimal, which means we want it to be normal, right? So we want to read. We're reading, so this number was written into a 16's place value system, PVS, or place value system. This number was written into a 16's place value system. So this E is in the 1's place. You always start with the 1's place. But then this A will be in the 16's place. And this 1 will be in the, remember, you have to keep multiplying, right? it's 16 times 16, which will be 256s, right? Just like, you know, you go from tens to hundreds to thousands, you keep multiplying by 10 each time. Well, here it's base 16, so we keep multiplying by 16 each time. So it's 1, 16, and then times 16 is 256. And if you have to go another one, I believe this is 4096. Hopefully that won't happen too much. But anyway, you do have to just keep multiplying by 16. Now, how do we read this out then? We want to read this out of the base 16. Well, we say I got a 1. I got 1 in the 256's place, kind of means I had a 256 pack and I filled it up once. 1 times 256, which means I must have had 256 to fill it up once, right? But then, look at this A over here. The A, and if you'll have to use this table for a while until you start to get used to this, but the A stands for 10. The 10 is in the 16's place. We filled up a 10 pack 16 times is kind of how I think of that. Let's put this back. Let's put this back. So we've got 10 times that we filled up a 16's pack. 10 times 16. And so that's going to give us 160 more actual marbles. Oh, for heaven's sakes. And then finally, in this last place over here, E. E means 14, right? So in the ones place, we had 14 to put in there. We had 14 to put in the ones. So go like this. 14 in the ones place, which gives you an extra 14. So if you add this all up, you had 256 plus 160 plus 14. Is that 430, I want to say? In the base 10 system. Is that what I had before? 256, 266, 270, 370, 430. Yep, 430. Okay. So that's the main difference. Okay, you're reading place value 16. So all it means is you have to multiply by 16. That goes that way. And I'll just ask you right now to try example 1B yourself. Follow the above as a template. See if you can get it. Okay, so again, this 16 is saying that we wrote this by filling 16 place values. We wrote this by filling in 16 type packs. We wrote this by, well, that's always the ones. But this would be the 16s. And this would be 16 times 16, which is 256s. How many 256s, how many 16s, and how many ones do we have? That's the question. The number of 256s is right there, 2. The number of 16s is a B. Maybe I should get that out of there. It's kind of crazy. The number of 16s is B, and then you have to go back up here and say, what's a B? Oh, a B is an 11. Okay, so the number of 16 packs is 11, and then the number of ones is, well, I got 5. 5 of those. So you go 256 times 2 is 512. 16 times 11 is 176. 1 times 5 is 5. You add this all up. 6, 11, 12, 13, 7, 8, 9, 693 in the base 10 system. Okay, assuming I did the math right. 160, 176, yep, 512, yep. 181, 681, 691. Yeah, that looks good. Cool. So let's go the other way now. So this time they're telling us, oh, that's normal. It's base 10. That's a normal one. We filled that up using base 10. That's the way we usually think. But what we want to do now is we want to fill up a hexadecimal place value system. So if I want to fill up hexadecimals, that means I'm going to have a 1s. I'm going to have a 16s. I'm going to have a 16 times 16 is 256s. And if we had to, we'd go times 16 again, and I believe that's 4,096. But notice we don't have to go that high. We don't have anywhere near 4,000. We only got 800. So good. That means we don't have to go that high. That means I can erase this. Good. Okay, so this is where you're filling in boxes, filling in packs. How many times, if I've got 844 loose thingies, loose marbles, whatever, how many 256 packs can I fill? I'm thinking 3. What is 3 times 256? 3 times 256 is, oh boy, 18, okay, 750 plus 18, right? So wouldn't that be 768? So that would fill up 50, 7, that would suck up 768 of these loose thingy-wingies. Filling up 3 256 packs will suck up 768 marbles. Subtract, how many loose marbles do I still have? I still have 76 loose marbles left. So you take your 76 loose marbles, you come over to the 16s, and you say, how many times can I fill up a 16 box? 4 times. You could fill that up 4 times, because 4 times 16 is 64. 5 times 16 is too many. 4 times 16 is 64. So you can fill it up 4 times. And then you still got 12 left. So you have to come over to the ones place and say, okay, I got 12 to put here. And again, please don't do that. That's not what you're going to do. You got 12 ones. Well, you have to use our special symbol for 12, which is a right there, right there, right there. It is a C. We have to put a C here. And so the answer is 3, 4, C. And you put a 16 there to emphasize that this is a hexadecimal number. 3, 4, C. That's supposed to be a C. I suppose somebody might think that was a scrunched up 6. So let me write that again. 3, 4, C, base 16. Want to try this next one yourself? 730 normal cupcakes or marbles or whatever they are. Filling in hexadecimal. 1's place, 16's place, 256's place. Again, I don't have to go farther than that. I don't need a 4,000's place if I've only got 730. So what we got to do here, we got to do something like, how many times can I fill up a 256 pack? More than once. I could fill it twice, not 3 times. I don't quite have enough for 3 times, but I could fill it twice. Sucks up 512, right? So putting a 2 in the 256's place sucks up 512. Well, how many have I got left then? 730, suck up 512. Do I really have 218 left? 8, 9, 10, 1, 2, 3. Yep, I still got 218 left. Wow. So you get your 218 left. You come over to the 16's place and you say, how many times can I fill that up? Well, more than 10 times. This might be where you get out a calculator and you go like this. You go, I've got 218. I divide it by 16, and it goes 13 point something times. I don't care about the point something. It's a 13. How do you make a 13? You make a 13 with the letter D. So I'm going to go over here, because that's a 13. And 13 times 16 is going to suck up how many? Well, 13 times 16 is, that sucks up 208. So if I suck up 208 more, notice I've still got 10 left. Pardon me, I've got 10 left to put in the 1's place. And you might remember that A is our new and improved 10. In the hexadecimal system, we use an A to represent 10. 2DA. That is our hexadecimal version of 730. Cool. So it's in one sense, it's all the same thing as what we were doing last time. I think it's healthy to take another night, so to speak, and work on these same kind of conversions, work them a little better. And just to make it interesting, we added hexadecimal to the mix. Now you're ready for program.